So welcome to Let's Build. It's another week has passed. We have another session. So today's topics are more condensed. So we are not touching that kind of large technical area, I would say. But these topics are still very much relevant. And as the next session is only in 2 weeks, this session is a bit lighter. So you will have some time to wrap up the code that you are working on yourselves, so you can add more features to your applications or polish things that you haven't quite finished. At least from the feedback I got from Discord, is that some of you have started to work or haven't really gotten a chance to kind of complete all the exercises we've been doing previously. So in the kind of from this point of view, I would want to slow down a bit with the progress, not add too much topics on top of this, and have you complete the tasks that have been previously, so that kind of you can follow along better and get kind of more value for yourself out of this. So let me just quickly see. So how many are there? Hey, quite good numbers, better than last time, I think. So how are you feeling on this wonderful spring morning? Well, not morning, day, afternoon. It's afternoon already. Is somebody brave enough to speak?
Finally, spring is here. From my perspective, I'm very happy, but not happy how long it will be, the weather like this outside.
Well, it's always a kind of game of luck before midsummer regarding the weather. Okay. But yeah, let's proceed then with the presentation part, and after that we can get into the live coding. So we'll be covering unit testing. So this is a topic which I want to cover because, in my opinion, the companies in our market don't necessarily always follow these practices listed here. So we don't always see people in interviews when we kind of talk about the things that they're doing. And even though this sometimes feels like extra, or why do we even need to do these things? I want to kind of provide some background to why I believe these things are important, and also showcase how we approach this and how we do this. And I see something in the chat. Okay. Yeah, if you kind of hear, if my mic has some noise, please let me know, because I'm sitting at an open window. I hope it's fine, but in case it's causing some issues, please let me know. Don't be shy about it. Yeah, so these are the topics that we'll cover. This will be more philosophical in a way. We'll be looking at code, I'll be writing code, but in the same time, I will try to argue with you about why these are good things to do. And if you have counter arguments or want to ask questions, this is the topic where discussion is more than welcome. But okay, so yeah, today's topic is this week. Next week, we actually don't have a session. So next week, we will have community event. So we have a meetup where we'll have speakers talking about Cosmos DB and about Blazor. So if any of you were interested in Blazor specifically, then we are bound to have a great speaker on next week. But the next Let's Build session is then on May 27th. And for that, the focus will be already deploying and hosting on Azure. So if you've been so far, you'll be building up your web application and adding features and concepts and adding things to make it work. Today's session is how to make it work better and ensure that it's working even when you do changes. But from there on, we'll kind of move more towards using Azure. So I expect that some of you might have questions later on about kind of setting up Azure account. If you are students, then you have ability to kind of use your students' IDs to set up kind of an account where you have free credits. So that's definitely something to use. If not, there's a possibility to use, of course, that kind of trial period where they give you credits, or if you have MSDN subscription, that also comes with free credits that can be used then for practice and training. So those are the options, but specifics, if you need help and support, that we'll try to handle in advance then in the Discord. Yeah. One more thing related to next events that I want to mention is that as you see, we are not that many who are joining the calls every week. In fact, last time it was something like 3 or 4 people joining. And because of that, we have had to make some changes on our side to just manage expectations of guest speakers. And it means that we'll kind of narrow down the way how we approach these events. So currently we've been recording every presentation and putting on YouTube and kind of having this more formal style of me presenting and you just following along. With this small of a group, and I'll announce this afterwards also in the Discord with the details. With this small, I see that it's more valuable for us to have more interactive experience. So starting from next session, we'll switch to using Discord as the main platform for the calls. And in addition, I'll change the style a little bit. So I would like to start showing your code parallel to what I'm doing. And as we have kind of 2 weeks in between, it's also a good opportunity for you to catch up or decide how to proceed with those solutions. So it also kind of changed from our perspective that we'll try to have reference, at least starting point, which you can also borrow ready before the session starts, not only after the session starts. So that there is more chance to do code along, and it's actually in this small of a group is something we can try to manage. But if some of you for some reason haven't subscribed to Discord, please do that. The invite I'll copy to chat actually in a second. So just in case. But yeah, through that we'll then coordinate more about the next sessions. So they won't be no longer this kind of public activity as we are quite late in the program already. But yeah, materials all will be available on GitHub. Also this presentation with the task for next session. And the business case is still the same. We're building an application to help people to support, to manage event and organize events. So as next topic is focusing on deployment and hosting on Azure. So this presumes that you already have working functionality which you would like to deploy on the cloud and make it available for people, not only to yourself or whoever was able to join your laptop. So for this then, what you'll need to do, you'll need to deploy your web application and database to Azure. So you can do it manually, you can try to use scripts for that. There is the reading material in GitHub to kind of go through that and look through the tutorials. I would advise once you have managed to deploy it manually is to pick one automation approach, either through scripting if you kind of want to do it very custom way, or if you're using a source code repository Git, then Git Actions. Or alternatively, if you're using Azure DevOps as the source repository, in that case, I would you can use their build function to do deployment. But try to automate the deployment so that it's something that you can do by the click of a button. So not something which you kind of every time need to go to your application and do build. And as a stretch goal, I would then suggest to experiment with gated check-ins. So these are builds that launch automatically when we check in code in source control. Very useful in team settings if you want to make sure that nobody broke tests. We'll write them in a moment, but you'll see how useful they can be. And other thing to experiment is deployment slots. So making seamless deployments so that we have an application up and running and ready even before we are ready to switch off the old version. So these are kind of more stretch goals. The base requirement is having web application in and database on Azure available for everyone. And after that, trying to do the automation of that deployment. Questions or comments so far? Okay, so the top vote. Okay. If there's nothing, we'll touch on this in the very end, but we can proceed with live coding part. And just find Visual Studio. Okay, now in the chat, or not in the chat, but in the participant list. So use the show hand function if you have actually used unit tests in some capacity, either by yourself or in work setting, or even kind of in advance for this lecture, that also counts. Okay, Andres and Antra, good to see. Diana, all right, good, good. So there might be some things where I'm repeating something you might already be familiar with, and we are not aiming to do kind of heavy test-driven development today. We just kind of want to go through the basics. But follow along, ask questions, and if there's anything that you've been curious about or always wanted to ask or to clarify, feel free to add those questions to the conversation. Everyone will benefit from that. Okay, so today I'm starting from my application. I did follow along some of the tasks for database creation, but I'll be honest with you, I didn't get all the way through during the talk last time. So I'm somewhere in the middle and don't actually yet have the database connected. But that doesn't matter for the purposes of the exercise because we need to do testing, and testing, well, is something that you can start from any point in the project, be it an old project that you plan to do changes later on. Tests will help you to ensure that you are not breaking existing things, or it might be a new project where you might go kind of test-driven development approach, where you start with the tests and only after that start to write the functionality and flesh out the functionality, making sure that you in advance have planned out how things will work. Okay, but let's start with tests, and I'll try to do things the wrong way. First, kind of explaining the basic concepts for tests, and after that we'll get to why we need dependency injection and why it's included in today's topic. So yeah, my application. So we have a database project, this test data generator. I have my web project, which has my controllers, models, and views, and also mappers. We touched on during last live coding session. I led our models and our services, which have the logic that, well, implement specific logic that would be very business-like, but in my case, it's just sample data, so nothing much to test here. So yeah, actually, before we write tests, I actually need to fix this in this case, because in this code, there's nothing really much to test, so we generate data and then spew it out. But for adding participant, let's just do some pretending and actually add some logic. So the question that we oftentimes get is, what is it that you need to test? And my take on it is we don't need to test. So that's a line. I don't really care if I have a test covering this line. This assigns a value, and normally you wouldn't expect anything more to happen here. The equals sign, well, that's something that the framework does. And if we, for example, would person age in 5 years, well, business might have a reason why we want to know that. But that would be age plus 5. So it is kind of an operation. We are doing some logic. So this starts to smell like something where we want to have a test covering it. But it's once again questionable and depends on how the project views these things, because what are you testing here? It's just an add operation and its specific amount by which we increase. So the test will ensure that equal operation, equal sign works correctly. Well, we don't need to test the framework. That the plus sign works correctly. Well, we don't need to test the framework. Math works, presumably, otherwise, well, physics are broken. We could test add plus 5. So that is actually kind of a business specific condition, which we might want to test. But it also means that we kind of have this encoded, kind of double checked in the test as well. So it's not only described in the logic, but it's also then described once again in the test. If you wanted something that it's not easily changed and not broken, so if this 5 is very significant, then that additional test you write for this line of code, that will actually prevent accidentally a developer accidentally changing it. So for example, somebody goes through that, mistyped something and didn't notice that it's actually no longer doing what it's supposed to. So now it's changed. And the test would fail and we would notice this. But sometimes you don't really want to do that kind of double controlling because you might have other more glaring issues. One thing that is actually always, I think, needs to be tested if we have any branching conditions or any loops in place in the code, because those always kind of create space for possible confusion or possible mistakes. So int I equals 0, where I is smaller than person's age in 5 years, I plus plus. Okay, so if we have a loop that does something, doesn't really matter what does it do. Here we have suddenly several points of failure. So we could be assigning the starting point incorrectly and thus not going through the loop enough times. We could easily miss if this is less than or equal. So that's a specific thing to check in tests. And we might have some more specific iterator here working something differently. So loops are always something to look out for and to think about. So, well, if somebody will change this code and add something or rename something, what are the things that they could easily get wrong and that will break the way that the code is supposed to function? If conditions. That's the standard point which every kind of testing class you go in the university will kind of pick up on. So conditions is something to test because on the border of the kind of equal sign or more or less sign, there's room to make an error in terms of how you interpret the rules and how you write the code or how you kind of understood what was required. So these things need to be validated, and especially when we start to get more complex conditions, that validation also needs to become more complex to accommodate. But for now, let's say in 5 years, more than 100. Let's say we have a weird business rule. So if a person passes 100, then we want to person, so what do we want to do? I'd say no, 100 is too abstract. Let's say if in not 5 years, so if person age, let's make it less convoluted. So what's the pension age in Latvia currently? How long until I get to go to retirement? Come on, you should know that. 70, something like that.
We are too young to know that.
Come on, prepare for the future. At least you should understand what kind of politicians you should vote against if they say that, well, we need to raise the pension age or retirement age. Well, let's assume it's 70, and somebody will correct me in the comments if it's not. So yeah, if it's an elderly person, we most likely want to take it into account when we book the tickets for him because he might require special accommodation. So for this, we actually would need a way how to identify this. So special accommodation. And it might be a field that's kind of offered to the user on its own. So they might kind of request it themselves, but we want to be kind to them. So when they acquire special accommodation and when we know that they are elderly, what we want to do that, well, we still want to care for them even if they don't want to admit that they require special accommodation. So person, special accommodation, whatever they entered, but now we're gonna set it true. And then we would just kind of save it to database as it is. Okay. Now that we have a method that's more testable, and I think we also had a method here that called the logic, and it actually also had some conditions in it. So this is also very much testable. Let's start trying to write tests. For that, on the solution screen, I will add a new project. So we usually do testing in separate projects. And as mentioned kind of in previous time, there are kind of multiple types of testing frameworks. So NUnit, MS test or XUnit. For today, I'll probably just pick MS test, but it's kind of depends on you which one you select because they're pretty much very similar in terms of how they perform. Some being maybe older with larger background, but yeah, C# unit test project. And it's asking for name. So the way that we usually structure code for tests is that we repeat for which project, for which project in the application we actually are writing the tests, and for every project you get separate test project. So in this case it would be, let's start with the controller. So super event app. Test. Next, so .NET Core Framework, that's okay. And we get a nice empty project with one file called unittest1.cs. My personal preference is that when we write tests, we try to mimic the structure and the names of the classes that we test on some level, maybe not one-to-one, but at least on some level. And this is event. Yeah. So, and we want to rename the class name as well. So didn't misspell. Yeah, whenever I talk about structure or naming of things, these are debatable topics. So your project that you work on or kind of the team that you work in might have different rules and guidelines, and they probably have very good reasoning why they're doing things that way, because it might be logical for them, and that might be the convention they already taught everyone else on that project. So even though you might, when you're kind of come into a new project and might not be familiar with that specific approach, different doesn't always mean wrong. As long as they're doing testing, there is nothing in theory that you should object, even if they call their test projects abcd.test and second test project abch.test. Well, that's their weird logic how to call projects, whatever. They have tests, so it's all good. But yeah, for my practice, I kind of like to name this way because it's easy to find then what am I supposed to test. And with test methods, it's also kind of, I prefer to have very long names. It's also a very kind of debatable topic, so how to properly name your tests. But what I like to do is then, what is the name of the method that I'm testing? Where did my test project go? Okay. So name of the method or action in this case, index. What am I doing? So I'm testing index, and I want to test what happens when I get a new person. So a completely valid person sent from the browser side. So valid data received. And the last kind of part of this 3-part segment is the expected outcome. And the expected outcome is that so saving in service is called. By the way, if I need to zoom in, please let me know. I have no idea how it looks on your screens. So 3 parts to the name of every test. Which method are we testing? What are we actually trying to achieve and do? And what is the expected outcome? And sometimes it's rather vague, so it might be no error or kind of specific action done or a specific value set to an object. So if anyone later needs to change your test, he has an understanding what we're trying to do and what should be the expected outcome. Because when the test breaks, you need to understand, is it breaking because it's a valid reason, or is it breaking because the requirements have changed and actually you need to change the test rather than going and trying to fix the code. But downside for this is we get very long method names, so there's that. Some prefer to have shorter or might have different reasoning how to do naming for the test methods. And then I like to remind myself, so arrange, act, arrange, act, and assert. So that's just something I like to put myself. So to put myself in the right mindset, so what I want to do and to give some structure. As arranged, so this is setting up the data and the objects that we need to perform the test. And the main kind of question here, so what were we testing? So it's event controller. So first I would actually need a dependency so that my test project seized my web project. Super event tab, okay. So I want to use an event controller. It needs a using to find where the class is located. And act would be what I want to do in the test. So usually you don't want to do too many things within one test. Instead, you want to have many tests in place. So, but we want to do index, hence name of the method. But we don't want to do just simple index. We want to pass some data to index, right? So we had an event controller, and this used the model. Okay, so we need the model. Just a sec. I will definitely not remember the class name, so I'll copy that. Test date. And let's call it a var. There we go. It doesn't see it because we don't know where it lives. We added using, so now it sees. Okay, so that creates empty object, and we actually pass it onto our index. And assert, here we would want to check the outcome of the test. So, and we get into a difficulty. So how can we check that saving actually called services? So how can we check that the object that the index method received actually got to the service? Well, we don't want to set up all the dependencies inside, because then you're talking about integration test. It's no longer a unit test. But unit testing is very tightly coupled with dependency injection, at least my view. There are alternative ways how we can do unit testing. You can do kind of use stabs, kind of do your own setup so the dependencies are not kind of hard coded. So we don't have things like, I'll show you what's the problem. So currently participant logic is a specific object that's where we create a new instance of it here. And there is no way to change how this behaves. It always will create an instance of this participant logic and presumably talks to the database, so it will create a connection to database, regardless from where we call it. So in that case, my test would be bound to know something about the database and have the database in place, just so it can test that what we're exactly testing, that we got a valid model state. That's quite a lot of things to kind of set up to check a simple condition. So yeah, to actually kind of proceed with the test and not have to go through all the loops, we will now stop with the test and actually we'll switch to dependency injection. And the main concept for dependency injection, it's one of the architecture design patterns. And if you try to imagine then, well, let's say you're trying to do something. Well, imagine a hobby you do with the things that you need for that hobby. So let's say it's painting. You need a paintbrush, a can of paint, and so forth. So these are all the dependencies that you need to perform the task that you want to do. And if we just create new objects for this task, then we are bound to have those objects in place, and kind of within the scope of this one method, it guarantees that those objects will exist. For testing purposes, it would be good that we would just do a dry run on the wall without the paint, or the paint not really sticking to the wall. Let's just try what we can do. For that, we would need to replace this specific implementation with something more abstract. And now let's try to, without actually doing dependency injection, look at ways how we could abstract it away. So we could create a public property called participant logic. I'll name it get set. And then we would just call not new on this one. And this would be just name it? Path logic. No, part logic. That's what I wanted. Okay, so this still works. But now this is still a specific class. And if I wanted the participant logic not to go to the database or do something else, I can't really do much with it. And besides, it's not really kind of assigned to anything. It's just a public property, so it will be null when the application runs. To help with this, what we could do is to use the constructor to assign the value for that. So public event controller Petri logic. My spelling today is horrible. Participant logic, no shortcuts. Let it be the long name so I'm not mistaken. New. Okay, so now theoretically our test could go and do something like this. So we created a new instance of the controller. This created an instance of participant logic on the controller when it was initiated. And we could say, well, no, please don't do that. So controller participant logic, it's actually a different thing. And here we would assign our mock object. We'll talk about mocks in a moment. But the issue with this approach is that, well, this mock object is assigned only after the controller is created. So participant logic presumably already tried to establish connection with database and kind of set itself up. So that's also not a very good approach. And here we come to a reason why I initially added this interface to the logic class. Because we want to be able to substitute the specific implementation of logic with something else while keeping the same kind of functionality signature that the interface describes. What we should be doing is not having specific class implementation here, but instead have the interface here. So it still functions the same. You can assign specific implementation of the interface to the interface just fine and it works. Thank God for object-oriented programming with all its paradigms. So this is the way how we could actually add a mock here. And I'll just add one library for the test so that we can do mocking, but alternatively, I could be, well, if you go very manual approach, how to do it, very basic approach. Where was my test class? Yeah, so in my test project, let's add a class. And this could be test participant logic. Oh, it's a class that implements just like our original participant logic. This one implements this interface. But instead of having the whole logic to connect to database, do something on there, this would just quietly do nothing. And in this case, return new list. Tame enough, doesn't need to go to database. So this is not yet dependency injection, but what we're doing is basically telling, well, instead of having the specific implementation of participant logic service, here, take this fake one. And in testing, you have these kind of terms, so you can have fakes You can have stubs, or you can have mocks. And the difference, at least kind of very generalizing it, so stubs and mocks try to pretend how the specific object would interact with things. With stubs doing mostly kind of specific implementation, and mocks is just kind of creating abstract object that will kind of, to everyone who asks, will pretend to be, well, I'm this interface, so, and I will do whatever you say, and you might set up some configuration for me how I should behave, but I'm basically a fake thing out there pretending to be the real service. And that's what we actually want to use. So I want to add dependency, a NuGet package for that. Browse, and the one that I'm gonna use is moq, M-O-Q, like it's originally a pun on the iMock U, so mock U, but yeah, quite popular. There are others. Reno mock, I think, was, or Reno or Rhino. No, okay, no, it no longer exists then. But yeah, mock-U is a popular one and the one I prefer to use myself. There are other, like AutoVac mock-U, and you can kind of probably find your own implementations if you so desire. But there's nothing wrong with using different libraries, whatever works for you and where you feel comfortable with those. So it needs some dependencies. Here you go. Take all dependencies that you need. We just want the test to be up and running. And while it's doing its thing, let me just quickly open documentation page. Almost. Yep, managed to drag it over. So documentation is right in their repository, but using it is really easy. So features at glance, I think they had a good quick start examples. Now this is good. Let's take this as a sample. And I'll show you in detail what it actually does. Okay. So mock, this is the kind of part of this library that we installed. And we wanted the mock to be for what was the name of the service? iParticipant logic. Here we go. Just the using, so it knows where it is. And with this, basically, we have a mocked service. And instead of having this new object, well, let's delete it. We no longer need it. Instead of creating classes for every different kind of interface that you might need, you just kind of write mocks which describe what needs to be mocked. Service object. And that's it. So this would run, execute, and assert. So what could we check on the assert? We never wrote that one. Assert. Okay, so let's check the result of the controller calling index. And type of, sorry. No, that will not work, sorry. Check what the actual result type was. I'm forgetting that one. My action result. Okay, now it didn't know about the specific type, now it knows. Let's add is not null. We'll check in this more specific asserts later down the line. There's actually a way how we can do testing for specific action result types. Just something that's currently slipping my mind. But in theory, what it allows us to do is that kind of these all return view. So what it says that once we have completed the controller section, we return the view. So the view will be the action result and show view will be the action result. But we might have more complex controllers and those might do redirection. So instead of returning view, we might have return redirect to action, for example. And that's a different type. So you might then differentiate based on the kind of if-else logic within your code to which action result did you get. But let's go back to our test. So let's check that we actually got a view back. Not very useful at this point, but assert. Yeah, let's just build this and run so we actually get to the test execution. Let's add additional features later. So left click, run tests. It will churn a little bit to build this up, but takes a moment, but only because I'm not on a very powerful laptop. Okay, build starting, so you can see down there in the output, so it's building. It needs to build things before it will be able to run the test. Although we can have the kind of unit tests running constantly in the background, which is actually awesome feature for smaller projects where you can afford the kind of load on the machine to have them available all the time. But for now, let's let the test run. It's taking some time here. Hey, it's green. What surprise. So let's just take a short look what we get here. So what did we test? From where the test is located, how long did it run? If everything is green, there isn't anything really to show. Good thing, let's dock it here on the bottom. Oh, didn't mean to put it there. What I meant was just put it here. Okay, so what it starts to show once we have test running, here next to the test method, you nicely see that, hey, this is green. And if you have multiple tests per class, that's obviously a nice thing to have in place. Then in the controller itself, you actually see that this part and this part was covered by that test. So model state was valid, and we actually got to this return view. So this whole code executed. If we would have a test that where the model state is not valid, and let's try to set it up. Once you have few good tests and know enough about them and why they're written this way, it's easy then to duplicate. So in my case, then index, invalid data is received, and saving service is not called. So we're not calling the saving service because data is not valid. So yeah, we can leave this just as it is. Model is okay. State. Let's add a model error. So as we are not executing the full MVC pipeline, so not all the things like model binding are happening, we don't really get errors here. So we actually need to add our own error here. And for that, we need to have a key. And let's say, what were the fields for the object? I mean, the view model. Let's say name test error. Okay, and let's execute just this test we newly created. So this one should go a different path through the logic. I do hope it builds faster next time. Yeah, so if we add a breakpoint, let's check if we actually, it works as expected. Let's debug the test. And this is actually a very useful way how to do debugging through tests actually, because this way you don't need to launch the full web interface. You can just focus your debugging on specific part in the code. Okay, so is valid is false because we added the error. And so the code skips the call to the service. Of course, now we see it, but it would be useful to know that it actually happened fully automatically instead of us just watching what happens in the test. So I'll add a check for the mock and for that I do need to consult documentation because I don't remember it. Sync methods, nope. Properties, events, callbacks. Verification. So we can verify that mock object didn't get a call to one of its methods. In this case, what we should have is our mocked service. And we should verify that add participant with, well, we could write down the test data that it was, and it's participant, so it's not really that specific test data. So is any participant. Yeah, so let's kind of break this line down before we launch it. Or actually, I could launch the test, so we don't need to wait for it. And let's break down what's happening. So after we ran the act part of the test, we got the results. That's good, but things happened. So mocked service was called or not called, but we don't know what happened. So we're asking the mock itself, please verify that this method, add participant, with these parameters. So, and this is a little helper. So it is any participant. So with whatever data that was passed of type participant, and it was called exactly 0 times. So it was never called. And let's just check that the method actually works and our test kind of previously. So this one should fail currently because this one should be calling once, and this should allow it to pass. Let's run the test. Okay, both tests run green. One thing when you're kind of dealing with tests and different verifications, sometimes it's a good approach, especially kind of in the middle of development and when you're kind of building up your application. Try some crazy things in your tests. So let's see if we can get it to actually to fail. Because if you know a specific condition under which test could fail, you could write consciously a failing test and check if it actually fails under that condition in the way how you foresee. Alternatively, you could just write the test so it validates those things and is green because of that. But I sometimes like to just check, okay, I wrote a test that passes, but does it always pass, or can I actually make it fail when things have changed? So if I change my code, will it? Oh, and it's no red. Okay, we don't want that. We want green builds. Okay, before we proceed, we've been at this for an hour now, and I'd like to invite everyone to take a break before we proceed specifically to dependency injection. So far, we've been able to write a test. We've been able to start do mocking, but we haven't been really doing dependency injection because, well, while we are providing the mock to the controller, the issue is that the controller already initiated this specific instance, and only after that we reassign something different there. So we're not really disconnecting it from anything. We're just kind of playing around with the notions and making it behave differently. So yeah, let's do a break for 10 minutes. After that, I will be taking any questions you might have about kind of what I've been presenting so far. And if there's something which I kind of went over too fast or where you kind of didn't get why things were connected or why I did what I did, those are the things where you should be interrupting me and asking the questions. But yeah, this passed and we're ready for break. So we're back at 10 past 5. All good? No. Okay. If nothing, then nothing.
If I can ask question about whole testing. So
yeah.
What I mean, how many tests do we need to create for each of our logic? For example, I know there is a border test, null equivalent test and stuff like this. So how we can evaluate how many tests we need?
Yeah, that's actually a very good question. So currently I have 2 tests. So one test, and let's look at the kind logic that we are testing. So from one perspective, what you're mentioning, kind of null tests and border logic. So that's kind of talking about any numbers or sequences we want to check the border regions. So most likely any value in between will not cause any problems. But for any sequence, the start and end point are the places where you might make mistake because you include too much, or vice versa, don't include enough in the from the sequence. And null checks, well, systems tend to do funny things when objects are not initiated, and sometimes it's actually a valid use case when the calling side might be sending null because there is no data. Yeah, so those are kind of database test cases, and you might kind of group them into several ones or split them out in very kind of granular as separate tests. It's more a matter of preference, although kind of the general trend is that if you split the test into smaller, more granular instances, yes, you have to write a bit more, but those are then more granular, and when they break, they kind of give more information what's broken. But you can achieve the same thing when you if you have one test and then validate kind of more data in the asserts. But of course, in each test, you should have only one ACT method. So that's something that I stand by. So if we are looking at structure, so arrange, we do however many things we need to arrange the test, but we act only once. So theoretically, you could kind of act again, check result again, and so forth. But that, in my opinion, is a bad practice, because then when the test breaks, well, we don't really know what was the reason why the test broke. It could be any one of those different ACT methods that caused that. So there should be only kind of one major reason for the test to fail. But yeah, in terms of the logic, what I look for is the different flows through the logic. So here we could go through the if, or we could skip the if block. And that means we at least need to have two different tests. If we would be checking for null, then it might be another than one or two tests, depending on how thorough you want to be. And with testing, it's always about how you balance kind of time spent on testing and time spent on adding additional features and functionality. And you might meet people who are more religious, who say that, well, every line should have a test covering it, or at least two tests covering it, kind of with different inputs. You might get people who say, well, there is a certain coverage percentage, so at least kind of 70% or 30% of all lines should be covered by tests. But I feel, while it's a good way how we set a KPI which we can check, so did our tests really are on approximate level there, it's not really good guidance for developers. So my own interpretation here is that look at your method, look at where the code splits execution. So we start to do different things based on different inputs. And every one of those different possibilities should get one test to kind of validate this branching point. We don't need to validate really what happens afterwards when the service is called. That's why we have unit tests. The service itself will have separate tests testing its behavior. But if you're testing this specific method, we should at least check both possible execution branches for the code. Did that answer your question, or was it too vague?
No, this is good. Thank you.
Okay. Okay, but we left off, well, I left off saying that while we have unit tests, and they do test one single unit, so that is this method, we don't really have dependency injection, and we are creating unnecessary instances of object which we are not using and overwriting. So for that, actually, we need a better way how to initiate these objects. And dependency injection as a mechanism comes into play and, well, solves it nicely with rather low overhead of additional code. Of course, if you don't write tests, you don't need to deal with this at all. Well, my code didn't have tests before, and it kind of worked. But we'll get into the good practices in the very end. Let's go through dependency injection. So, yeah, I'll just write some code here. And let's assign. And this no longer needs to be public, so it would be private. And in my test, I can't really assign it, but when I create my controller, I would be passing the mocked service object to it. So for test, well, it became even shorter and easier to read. What's not to like? Awesome. For the controller, this is also shorter in a way because, well, this is no longer polluting the public, is no longer publicly visible. So it's a bit better that way. Here we don't have this new keyword, so we can get any implementation of the logic as we want to the controller. Otherwise, nothing really much changed, but yeah. Now the question, how will we get it here? And that's the injection part of the dependency. So this is the dependency. We need this interface, the specific implementation of the interface, and we need to inject it. And for that, previously you had to use different separate libraries which dealt with this. So simple inject was, or Unity was some of the libraries that could be used for dependency injection. Once again, you can just browse NuGet store, kind of package store, and check for dependency injection. You'll find quite a lot of variants there, which everyone does things a bit differently, but most of them are pretty good by themselves. But as this is quite a common thing, if we want the stability, then nowadays MVC includes it out of the box. So let's look at this startup class that we have. So this runs when our application is, well, starting up, hence the name. And here under configure services method, we already are calling add controllers with views. So this tells that, well, once we set up MVC to work, we need to make sure that its own infrastructure can create instances of controllers and views. So it already kind of does some setup for things. What we need to do in addition, we need to, for the dependency injection to work, we need to explain that for this, for any particular interface, what is the specific implementation of that interface. So for our iParticipant logic, just a sec, I'm not remembering the correct name of the method, but I'll look it up in a moment. Okay, so add scoped, and I'll explain it in a second. And it's how was named the interface? iParticipant logic. Great. Now just the missing usings. Okay, so here we told whenever you see and kind of start to create an instance of an object that in its constructor requires to have iParticipant logic. For iParticipant logic, you will create a new instance of participant logic. and you just kind of set up the mapping how to find the specific implementation of every interface that you want to have configured in this way and working in this way. And as we have other kind of logic here, so mappers we were creating as static ones. If those weren't static and we instead needed to have instances of them, then we also would need to have iParticipant mapper, and we also would do configuration for it similar to this. So this just adds kind of this scoped, and add scoped means that we add add an instance of this participant logic that is scoped to the request. So once a new request will come in, it will have its own instance of participant logic. Alternatively, it could be add singleton. So that means if you are familiar with the term singleton, well, it will create only one instance of participant logic, and everywhere where it's needed, it will kind of give that instance of this participant logic. But we have to be careful and understand what is the behavior we actually want, because reusing the same class instance, especially if it has some private fields which might have their own state, means that we might have the situation where applications runs one way if you do things in one order and runs totally differently if you change the order of execution kind of the manual operations. So yeah, add singleton is something I wouldn't try to add, especially if I don't know the specific implementation and how well it would work from there. So add scoped, and this should actually run just fine. I'll even add a breakpoint here, and we are ready to test it out, so to say. Okay, then let it build, let it run, and I want it to hit the breakpoint so we can see it actually created an instance hit there. So on the first call, it actually shouldn't hit the breakpoint because we haven't yet called the event controller, I think. Let's see. Okay, so we're in our web page. We responded already to a request, but we're not yet in the controller. So let's view the list, for example. And here we hit on the breakpoint already. So logic is not null, so it was passed, but what actually happened was when MVC was understanding that, hey, I need this event controller to respond to the request. So I'll create an instance of it. How do I create it? I use the constructor. Well, I need this iParticipant logic. How do I create that? Let's look in the kind of bag of different dependencies. Hey, I have it set it up. Where was it? Yeah, there was something mentioned in the startup that iParticipant logic is participant logic. So let's create a new instance of this one. And what it would do, then if this requires dependency injection, then in turn it would create those dependencies as well and kind of go down the line until it kind of builds the whole dependency tree for execution. And it does it pretty fast, so this usually isn't a kind of significant performance impact. Of course, it takes some time to kind of do the lookup and build the dependency tree, but in most cases, the stability outweighs the downside of having that delayed there. So yeah, that is dependency injection kind of in the very short way how it's set up. And as you saw, the methods here are already set up when you start the application. You just need to start adding your own mappings for interface to class, and in your own class, in your own classes, then you need to start adding these constructors which just take interfaces. One thing to note, once you start to add dependency injection, you need to do it for all the parts of the chain. So if we want to have dependency injection in the specific participant logic, so if we wanted to have dependency injection in this class, We also need dependency injection in every class above it, so from which it's called. Otherwise, it's not really gonna chain down and flow down. So that's one thing to remember. But usually if you're starting to do unit testing, it's anyways in your benefit, so why not? Any questions, or can we proceed to code quality? Okay, I take it as a no. So for code quality, in the previous task, in the PowerPoint, there was the link to the quality standards set by Microsoft and the standard guidelines, so to say. If you, for some reason, missed that or didn't read, that's homework for you. Go and read it. The reason why we talk about standards, the reason why we touch on code quality, the quality side as well, it will not guarantee that the application works correctly, but it will reduce the possibilities to make mistakes if you follow the same standard in all the code that you write, especially if there is more than one of you working on the application. Then kind of following the same style means that the code is easier to read. And if the code is easier to read, people will read it and will follow it easier. So people are more likely to catch mistakes. So the standard you pick doesn't really matter as much as the practices around maintaining that standard and your own kind of approach to the quality of code. You could kind of tailor your own standard. For our projects, we usually just kind of take Microsoft's standard and add any specific limitations or alterations that we feel that we need. One thing that's kind of I see most important is agree on how you do naming of things, because naming is hard and people will start to name things in many different ways. The way I showed you how I prefer to do names for tests, it's something that we have described in our projects. Then, well, this is the way how we name tests. This is an example, and this is the reasoning why we do it. And so people, when joining project, can understand that and can follow that same example. The way how we enforce code quality, we can use automated tools. SonarQube is a good option if you kind of want to automatically run and check everything on your code and are working in more kind of company environment. But there are also plugins for Visual Studio that you could install that also allow you to kind of do validation against standards lists. By the way, also if you do JavaScript or TypeScript or any kind of front-end development, for those languages, there is also available this ASLint that does a lot of kind of validation specifically for those technologies. So there are ways how to enforce following the standards through these different approaches. But the main part is having people to understand the standard and what is the benefit of it, so that you can set up processes where you can do code reviews. Remember when we were looking at in the very first lesson when there was this Git showcase and we were talking about pull requests and how actually the code is merged to the server. Pull requests and their review is kind of very important in larger team environments. Sometimes it's skipped because it takes time to do a review of somebody else's code, and sometimes people don't feel comfortable doing the reviews. But if done properly and if done with the right attitude, I would probably say it like that, code reviews help people to learn because they see how others solve problems. They help people to align on how to write code, align the style of writing the code, and they also help to catch mistakes. So all excellent reasons why to do code reviews. And in code reviews, it's kind of up for you to agree then how nitpicky are you and how strict are you with following the standards. Because sometimes it's not really the end of the world if you miss a comment for a specific property or for a specific method, or if the returns is not really explained. Not a big deal. You kind of describe the main thing in the summary. But in my, once again, my personal view, the larger the project, the more people working on the project, the more time the project will be alive and supported, the more attention you should be paying to how you document things, how you name things, and that you all follow the same approach. Because, well, everyone has heard this, that you should, once you look at your own code after a couple of months, there's probably, you're looking at something very alien and wondering who and why wrote it. In projects that span multiple years and many products that are being built by the companies here, and also sometimes you build something one-off for a client, there it can easily span larger spans of time in between, where you could have teams changing, people leaving the company, coming back, different people being onboarded, but you still need to be able to work on the same code base and not rewrite it every time. So setting standards and following them is kind of important, and I wanted to emphasize it here in our discussion. What's your experience has been with coding standards? Have you been kind of forced to think about them by somebody, or have you been reading about something like that?
I have read something about code standard, but I use Microsoft standards. So it's like a documentation. It's documentation in our website.
Mm-hmm.
So
Yeah.
like in camel case, it's as I correctly understand, the camel case, it's a function name and values name. Variables is Pascal code.
Yeah.
Oh no.
So local.
No, another way. Yeah.
So local variables are then named differently, but if you're kind of having any public names, those are then have their own naming rules. And people might disagree on this. So we actually, I do remember that in my project, we had one of our bar events and we had an extended discussion, which I kind of did the evil thing and kicked off, where I asked people, so what is the correct way how to reference private, well, let's call it I. So yeah, so we might have this private field, my participant logic. And what would be the correct way how to reference it? So from one side, there were kind of two sides already in the group. So from one side, what you could do is be very explicit and say that, so from this class, take the field called participant logic. And the way how you differentiate that it's a local variable or a class variable is by class variables having a prefix of this. And that's, in my opinion, a valid approach. Microsoft's own samples oftentimes, let's see if it's, yeah, own kind of examples sometimes go with a bit different conventions. So local variables still what you expect them to be. Class variables are always with an underscore. So you don't have to type this and it's less symbols. Also a valid approach. But I mean, once two groups meet and they have differing opinions, they'll find many reasons to disagree about something kind of small, but then again, you're asking the other group to do something which they don't think that they should be doing. So coding standards don't, well, you need them, but you need them specifically for the purpose to agree on how to do things. And sometimes they might cause a lot of discussions, but that's part of the fun. And you should be having those discussions because through them you get better understanding why you're doing the things the way you're doing them, especially if in an older project where things have been set up before you and you're not really aware of why they are built this way. Yeah, one thing I'll touch on kind of project splits. So what we did here and also in the labs, we tried to split the application into multiple projects. So we had this initial web app, but then in addition to that, we also had separate kind of class libraries, which contained either models, either services, or for database, they were separate project. And it's, as I see, kind of a matter of preference. For smaller projects, definitely there is no one rule that fits all. But once again, for larger projects, separate, in one solution, you might have separate projects, and these projects might be shared by different solutions. So I'll give you an example. So we might have an API, a web API, sorry, that has its own kind of data models, like we have here, super event models. And it's working just fine. And one day you decide you want to build front end for that. And that's not really part of the initial solution. A separate team is doing that. So they will have their own front end solution where they build only the front end part. And if they communicate with the backend, they will do that through the REST interface. So they don't necessarily need to have the same models, but it's handy if they can share the same models, because then you don't need to do the update. If the model changes, you don't need to do the update in both places. And so you start sharing projects. So with sharing projects, you start kind of having more dependencies. And at that point, it's important that somewhere somebody tries to kind of draw the dependency map. Not on the very kind of class level. The compiler will be very good to kind of warn you that, well, here you're trying to do a circle dependency or something like that on class level, or infinite loops or something crazy. But on project level, it's important to kind of do a drawing. It just kind of boxes connected by lines, nothing fancy. But to understand then how are these projects interconnected, and if it's in a logical and consistent way, so that not every project tries to speak to any other project. And the simpler this connection kind of structure is, the easier for you it will be to do changes, because every additional dependency means that contents of this project are used somewhere else. And so if you do changes to any contents of this project, you risk breaking something else. So by kind of controlling how the structure looks like, you can minimize the risks of kind of something breaking when you should change something in some other place. But there we can already touch on application design, not just pure code quality. But that's the reason why in our samples, we've been kind of trying to split things up into several projects to make things more modular, and also try to give every project some specific roles. So models project is the place where I would collect all the domain object models. Service would be the place where I collect all the logic services. And then for each of those, I probably would have a separate test project testing that service. So yeah, that's kind of, sorry for a bit ranty part, but that was the discussion or kind of the things that I wanted to tell you about code quality. Nothing fancy to show, because I think how to document a method, well, yeah, you do this and press enter and write some text, done. Yeah, you document the method. Nothing much to show in the code, but I wanted to speak a little bit about these things because the project I work in, it's a very hot topic, if you wish, because with time the project grew in length so we kind of can experience all the reasons why we should maintain good code quality. But yeah, do we have any questions about testing, about dependency injection, or if you wish something about code quality, or the way how we structure the code? Okay, I'll take that as a no. And yeah, for once again, just to remind you, so for next event, we are looking for deployment and hosting on Azure. So you should go through the materials linked and try to kind of do the deployment of your web application to Azure and try to automate that. If you're using GitHub, then it would be Git Actions. If you're using Azure DevOps, then it would be kind of Azure DevOps has its own deployment pipelines. So those are the builds that you would. And if you still want to do more, then there are things that you can experiment with. Although based on the comments, if you've fallen behind and haven't really kind of gotten as far with your own application, I would suggest that you at least get the web application running to a point where you have the web app loading and doing something and a database from which you load data, because it will be easier then to kind of follow along with this one. And we have 2 weeks until the next event, so that is on May 27.